Binary ionic compounds. Binary means containing two elements. So these are simple ionic compounds. Ionic means it contains a metal and a nonmetal. And the cation, the positive ion, is the metal. And the negative ion, the anion, is the nonmetal. Naming. So naming is pretty straightforward. You name the metal right off of the periodic table, and then you follow it up with a nonmetal, changing the ending to IDE. So if you have oxygen as your second element, the ion name is oxide. Fluorine, fluoride, phosphorus, phosphide. You kind of get the picture. Okay, so let's do a couple of examples. CaCl2. So Ca is calcium. Find that on the left side of the periodic table. And you'll find the metals on the left and your nonmetals on the right, kind of up towards the top right. So this is calcium followed by chlorine. Don't worry about that number there. For binary ionic, we ignore the numbers. So calcium, and it's chlorine, so it becomes chloride. So calcium chloride, Na2O. So Na is sodium. Oxygen becomes oxide. So that's all you have to do for naming simple ionic compounds or binary ionic compounds. Writing formulas, there's two different methods you can use. There's the crisscross or cross and drop. This is probably what you used previously. And then there's the zero sum. For simple ionic compounds, there's no real difference, both equally useful. But when you're getting into multivalent metals, zero sum rule really works better. Okay, crisscross or cross and drop. Write the element symbols, the metals first. Get the numbers of the ion charges from the periodic table. And then you cross and drop just the numbers. And these numbers will become subscripts. So the charges aren't involved in the dropping and the crossing. Subscripts indicate how many of each ion is present in the compound, and you reduce subscripts. So if you have if you have a 2 and a 4, you would reduce these to 1 and 2. You would divide each of those numbers by the smallest number. If you had 5 and 10, well, divide both by 5 and you get 1 and 2. So you reduce subscripts if you can. So the first example, sodium oxide. So sodium is Na and oxide is oxygen, so it's an O. From the periodic table, we know that this is group 1, so it's a +1. And this one is group 16, so it's -2. And then what you do is you cross and drop the numbers. Ones, they still cross and drop, but we don't write ones usually. So this would become, chemists are efficient, so we don't write a number that doesn't need to be written. 1, just the element symbol indicates that it's there. So if there's no number associated with it, we know that that number is 1. So we know that this is Na2O1, but we don't have to write the 1. So the 2 came across to the sodium and dropped down. The 1 went across to the oxygen and came down. All right, another example, potassium chloride. So potassium is K, chlorine is Cl. So this is +1 and -1. Why did I write 2? -1. So again, you cross and drop, but we don't have to write ones. So this becomes KCl. So if they have the same number, they're actually going to cancel. And I'll show you that in the next one. So we've got zinc and we have sulfide. So sulfur. Zinc is +2 and sulfur is -2. So if we cross and we get Zn2S2. We can reduce these. 2 goes into both of them. So that would be Zn1S1. So if they have the same number, they will cancel each other out because you're going to reduce them. You can divide 2 into both of those numbers. Now, the zero-sum rule. So you write the elements symbols first, just like we did for cross and drop. And you get the numbers of the ion charges, just like we did before. Now, the total positive charge for the cations must add to the total negative charge of the anions, and they should sum to 0. That's why it's called the zero-sum rule. So that's why it's called the zero-sum rule. Multiply the ions to get the ions to add to 0, and then the multiplier becomes the subscript. So sodium and oxygen. So Na, we know, has a charge of +1. Oxygen has a charge of -2. We can bring the total positive charge up to +2 by multiplying by 2. So we times this by 2, we will have a total of 2 plus. And if you add that to your 2 negative charge, you get 0. This multiplier becomes the subscript. So this is Na2O, potassium chloride. K and Cl. So this is +1. This is -1. They add to 0. So the formula is KCl. Calcium chloride. Calcium and chlorine. Calcium's charge is +2. Chlorine's charge is -1. So I have to make these two numbers equal. So if I multiply the -1 by 2, I get -2 total. That plus the +2 equals 0. So this becomes my subscript. So this is now CaCl2. The multiplier is the subscript for the same element that you multiplied the charge by. Let's do one last one. Okay, aluminum oxide. So we have aluminum and we have oxygen. So aluminum is +3. Oxygen is -2. We can't multiply oxygen by anything to get 3 because it has to be the multiplier has to be a whole positive number. But we can multiply both of these to get a number that they both go into. If we multiply them by each other's number, we get 6. So if you can't multiply one of them by a whole number to get the other charge, multiply the two numbers together. So If I multiply 3 and 2, I get 6. So to get aluminum to plus 6, I have to multiply by 2. So my total positive is plus 6. Oxygen, to get that to 6, I would have to multiply by 3. So that gives me a total negative of negative 6. Now, plus 6, negative 6 added together give me 0. So now these numbers have become the subscripts for those two elements. So the formula is Al2O3. The zero sum might seem like more work at this point, but it's going to pay off, I promise. So that's a short video into binary ionic compounds, naming, and writing formulas.